Hey, now I'm going to talk about page 5 and 6. So I don't have time to do every one, but we can look at this one together. This should be 1 left and 5 down. So we go 1 left, 5 down. Bam, peep rhyme. 1 left, 5 down. R prime. 1 left, 5 down. Q prime. So here's this shape. Rigid motion should stay the same shape. Let's read our coordinates. 0, -4. 2, 0. 4, -2. All right. Now we want to reflect over y equals x. I don't know why y equals x, it just does. So if I pick 5 as x, y has to be 5. If I pick 4 as x, y has to be 4. If I pick 1 as x, y has to be 1. 1, 1, 5, 5, 4, 4. This is the line y equal x. So now I'm going to flip it over this one, and I think we figured out a rule. These guys kind of swap. So instead of 2, 0, we have 0, 2. See how those swap? R prime, instead of 4, 2, we should be 2, 4. So we're there, -2, -4. Oop, that's a +4. -2, +4. So look, yep, they just swapped places. -2, -2, 4, 4. So let's plot this one. If I swap positions, it looked like this. Let's plot that. -4, 0. That's P double prime. Okay. Awesome. Good job, guys. Now, I want to give you a little direction here. Give some of these a try. I'm not looking for perfect, but I am looking for you to try each question. It says, describe the sequence, and the word sequence is misspelled, don't worry, put a little E in there, and that means combo, more than one. So that means that maybe there's more than one answer, could be more than one answer. I'm just gonna give you a possible one, and if students in class get different answers, don't judge, okay? But if I spun this around, right? Doesn't it look like I could spin this and at least getting it facing the right direction and then move it over 4 and down 3? That's looking really good. So if I spun it 90 degrees clockwise, now it'd be here. And if I just translated it, 1, 2, 3, 1, 2, 3. So that's 3 to the left, or 3 to the right, and 3 down. Beautiful. Think through some of these, and again, there might be more than one answer. You might be close to an answer. 90-degree clockwise rotation. Okay? But just think through these, and I'm interested to see in what you guys come up with. All right? Okay. So now, after you finish these, pat yourself on the back. That was a lot of work. But remember, I'm supposed to make sure that you're busy for the whole 90-minute period. Okay, so what can we do on the back here? I think I'll go ahead and give you the solutions here so you can feel like you know what you're doing. And so let's see, tell whether each of these has a piece of line symmetry, if so. Yeah, this feels like stuff we've been working on. So I think that you could fold it at that line, and I can't really fold it on the diagonals or horizontally. So this would be one line of symmetry. We worked with this B for quite a while, and so I think if we folded it this way, that would line up, one line of symmetry. Okay. What about these? We know this one doesn't have any. It feels like it does, but it doesn't. So we should just leave this one blank. This one, 1, 2, 3, 4, 5. 5 lines of symmetry. We pretty much had that one before. This one looks like we could fold the flag here. It's looking like it. This one kind of the same way. We could fold it here, but I think we could also fold it there. So it kind of looks like a letter X if you boxed around the letter X. Okay. Let's figure out if we can tell whether or not each figure is rotationally symmetrical. If so, give the angle. So that's pretty easy. If it's the angle, we just take 360 divide by the order, and that will tell us the angle. Okay. So spin this. Does it look the same? No. Does it look the same? Ooh, maybe. Does it look the same? No. Does it look the same? Ooh, yeah. Interesting. So it looks the same upside down and right side up. That means if I spin it all the way around twice, it looked like itself. So that has an order of 2, and 360 divided by 2 is 180 degrees. Cool. M. If I spin it, now it is not an M. Now it's a W. Still not an M. Kind of looks like an E. And now it's back to an M again, but I'm right side up. So this is no. Oh, this is kind of cool. It's like a fancy hexagon. So this one looks like if I spin it, and this is the top, here, 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 and then at the top it would line up. So that's an order of 6, or 60 degrees as the angle of rotation. Now, ooh, our triangle. I think this one, if we spun it, if this was the top, here it would line up, here it would line up, and then again when I got back to the top. So that's a 3 order of symmetry, and 360 divided by 3 is 120. We want so badly to flip this up, fold it, but that didn't work. But when we flip it upside down, ooh, it's the same parallelogram. When we flip it right side up, same parallelogram. So that's called an order of 2 when it looks the same right side up or upside down. So 360 divided by 2 is 180. This guy, this is a scalene triangle. All these are different lengths. So I think no matter how I spin this, it looks the same. So this mystery of the point symmetry, we'll talk about it next time in class. But technically, it means if upside down and right side up is the only time the shape looks the same. Okay, that means it must have an order of 2. So the quickest way to determine if something has point symmetry is if it had an order of 2. So when we look up here, we had 3 that were orders of 2. This weird crowbar looking thing, the parallelogram. And, oh, I said 3, but I got that wrong. That just says it. That one was not. So they do any of the above? Yes. This thing and this thing. Thanks for joining me. Look forward to seeing you guys on Monday. Do your homework.